7.9. Suppose the frequency of the source in the previous example can be varied. What is the frequency of the source at which resonance occurs? Calculate the impedance, the circuit, the current, and the power dissipated at that resonant condition. It is the continuation of the previous question, right? Okay. Now, in the previous question, all these values were given. R, L, C and peak voltage. I am copying from the previous question. Peak voltage matlab V naught is given. What is VRMS? VRMS is V naught by root 2, that is equal to 200. Okay, now first point, what is the frequency of the source at which resonance occurs? Resonance frequency formula F naught. This is a linear resonance frequency. 1 by 2 pi root LC, 1 by 2 pi root of L and C, right? Okay, so F naught equal to 35.4 Hz. Okay, now second part, at resonance condition, XL equal to XC, so net reactance equal to 0. Circuit behaves like pure resistor. What is impedance? When circuit is under resonance, impedance equal to R and current I equal to VRMS divided by R. That is IRMS we are finding out. 200 by 3, 66.7. Power dissipated. In LCR circuit under resonance, circuit behaves like resistor. Therefore, power at resonance, phi value 0, cos phi equal to 1, power equal to V and to I. I value we got, there is actually VRMS value, VRMS into IRMS. VRMS is 200, IRMS is 66.7. Okay. Can you use this formula? Yes, power equal to I square into R. Resistance is given. IRMS value is 66.7. In the previous question, I explained how can we use this formula, right? Okay. At resonance, circuit behaves purely resistive. Maximum current flows. Power factor is 1. Voltage and current both are in phase.